Here we have the alternating series of -1 to the n plus 1 divided by 2 to the n. And we want to use the alternating series test to show that this series right here converges. And so again, to show this series right here converges using the alternating series test, we have to show two conditions. First, we have to show that the limit of a sub n is equal to 0. And next, we have to show that a sub n is greater than or equal to a sub n plus 1. So first, we can rewrite this as this. And the 1 over 2 to the n, that would be the a sub n. And then we need to show that the limit of a sub n is equal to 0. So this would be 1, and as n approaches infinity, 2 to the n also approaches infinity. And so we get 0. So we have shown that the limit of a sub n is equal to 0. And then next, we need to show that a sub n is greater than or equal to a sub n plus 1. So we have a sub n as 1 over 2 to the n. So we change this right here to n plus 1. Then in the place of n, we just put plus 1. And so we have, we can see that 2 to the n is less than 2 to the n plus 1. And now we do the reciprocal, 1 over 2 to the n. And we have to reverse the inequality sign. It would be greater than 1 over 2 to the n plus 1. And so, but this is a to the n, and this is a to the n plus 1. And so we have shown two things: limit of a sub n is equal to 0, and that a sub n is greater than a sub n plus 1. So both conditions are met. Then by the alternating series test, the series converges. So this series right here. So by alternating series test, the series converges.